Picture this. It's a cold Tuesday morning in January 1961. You're living in Goldsboro, North Carolina. Population 17,000. A quiet tobacco town where nothing ever happens. You're getting ready for work, making coffee, maybe listening to the radio. And above you, 20,000 feet in the sky, a hydrogen bomb is falling. Not from a Russian bomber, not from an enemy attack, from an American B-52. Our own plane. And this bomb, it's 260 times more powerful than the one that destroyed Hiroshima. Powerful enough to vaporize everything within 6 miles, powerful enough to send radioactive fallout from Washington, D.C. all the way to Atlanta. But here's the truly terrifying part. As this bomb falls through the freezing January air, it arms itself. Safety switch number 1, activated. Safety switch number 2, activated. Safety switch 3, activated. 4 safety mechanisms stood between that bomb and detonation. 3 failed. 1 switch, a single low-voltage trigger. That's all that saved America from nuking itself off the map. And the government hid this from you for 50 years. What you're about to hear is not fiction. It's not exaggerated. Every detail is documented in declassified military reports, Freedom of Information Act documents, and testimony from the men who were there. This is the story of the Goldsboro incident, the day America came within a coin flip of erasing the East Coast. But it's also about something bigger, because Goldsboro wasn't the only time this happened. It wasn't even the worst. Over the next 50 minutes, I'm going to show you a side of the Cold War that's been buried. A truth so disturbing that when it finally came to light, the government official who revealed it said, quote, "It would have been bad news in spades." That's a direct quote from a nuclear weapons engineer about how close we came to annihilation. So stay with me, because by the end of this video, you're going to know something that 99% of Americans don't know. You're going to understand why there's a field in North Carolina where the government won't let anyone dig, and you're going to learn about at least 5 other times when America almost accidentally destroyed itself with its own nuclear weapons. This isn't about Russia. This isn't about terrorism. This is about us, about how the most powerful nation on Earth built weapons so devastating that we nearly wiped ourselves out by accident, multiple times. Let's begin. To understand what happened over Goldsboro, North Carolina on January 24, 1961, you first need to understand the world these pilots were living in. Because this wasn't just any flight. This was the Cold War, and the Cold War was insane. Imagine waking up every single day knowing that at any moment, without warning, the world could end. Not might end, could end. That was life in 1961. The United States and the Soviet Union were locked in what historians call mutually assured destruction. The acronym is MAD, and it was. The logic was simple and horrifying. We have enough nuclear weapons to destroy you completely. You have enough to destroy us completely. So neither of us will attack because it would mean the end of both nations. By 1961, the United States had more than 24,000 nuclear weapons. The Soviet Union had around 6,000. These weren't small bombs. We're talking about weapons that made Hiroshima and Nagasaki look like firecrackers. But here's what most people don't understand about the Cold War. These weapons weren't just sitting in bunkers somewhere. They were in the air, right above American cities, right now, 24 hours a day, 7 days a week. The Strategic Air Command, the branch of the military responsible for nuclear bombers, had a program called Chrome Dome. Under Chrome Dome, B-52 bombers loaded with hydrogen bombs flew continuous patrols along the borders of Soviet airspace. The idea was simple. If the Russians launched a surprise attack and destroyed our air bases, we'd still have bombers in the air ready to retaliate. These planes would fly for 24 hours straight, refueling in midair, carrying enough nuclear firepower to level entire countries. At any given moment during the 1960s, there were at least a dozen B-52s in the sky, each one carrying nuclear weapons. Think about that. Right now, if this were 1961, there would be massive bombers circling overhead, each one loaded with hydrogen bombs, flown by exhausted crews on their 10th hour of flight, operating complex machinery in freezing temperatures at high altitude. What could possibly go wrong? The B-52 Stratos Fortress was, and still is, one of the most iconic military aircraft ever built. This thing is massive, 160 feet long, a wingspan of 185 feet, 8 engines. When it's fully loaded, it weighs close to 500,000 pounds. It was designed in the early 1950s to carry nuclear weapons deep into Soviet territory. It could fly 10,000 miles without refueling, it could reach altitudes of 50,000 feet, and it could carry 70,000 pounds of weapons. That's not a typo. 70,000 pounds. But here's the thing about the B-52. It was designed in a hurry. The Cold War was escalating fast, and the Air Force needed a bomber that could deliver nukes before the Soviets developed effective air defenses. So they prioritized range, altitude, and payload over, well, pretty much everything else. These planes were complicated, incredibly complicated. Thousands of moving parts, hundreds of systems that all had to work perfectly in extreme conditions. High altitude, freezing temperatures, violent turbulence, and crews that were often exhausted from 20-plus hour missions. The B-52s that flew Chrome Dome missions carried a standard loadout: 2 thermonuclear bombs. Not atomic bombs like Hiroshima, thermonuclear bombs, hydrogen bombs, fusion weapons. Weapons that use the same process that powers the sun. The bomb that destroyed Hiroshima had a yield of about 15 kilotons. That means it had the explosive power of 15,000 tons of TNT. It killed 80,000 people instantly and left a city in ruins. The bombs on a Chrome Dome B-52 typically had yields measured in megatons, not kilotons, megatons. 1 megaton equals 1,000,000 tons of TNT. The specific model carried on our flight, the Mark 39 hydrogen bomb, had a yield of 3.8 megatons. Let me put that in perspective for you. The Hiroshima bomb was 15 kilotons. The Mark 39 was 3.8 megatons. That means a single Mark 39 was 253 times more powerful than the bomb that destroyed Hiroshima. One bomb, 253 Hiroshimas. And the B-52 on our flight was carrying 2 of them. Now you might be thinking, surely these bombs had safety features, right? They couldn't just go off accidentally. Well, yes and no. The bombs did have safety features. They were called permissive action links, or safing mechanisms. The idea was that the bomb would require multiple deliberate actions to arm and detonate. You couldn't just drop it and have it explode, in theory. But here's what you need to understand about these early Cold War weapons. They weren't designed with safety as the top priority. They were designed to work, to detonate when needed, to not fail when the president gave the order to end the world. Safety was important, sure, but it was secondary. The Air Force's biggest fear wasn't that a bomb would accidentally go off. Their biggest fear was that when they needed the bomb to work, it wouldn't. So they designed these weapons to be as reliable as possible, which meant, in practice, that they were easier to detonate than they should have been. The Mark 39 had 4 safety mechanisms. We'll come back to exactly what those were later, because understanding them is crucial to understanding just how close we came to disaster. But for now, just know this: those 4 mechanisms were all that stood between an armed nuclear weapon and detonation. 4 things. That's it. 4 switches, 4 triggers, 4 components that all had to fail before a 3.8 megaton thermonuclear bomb would vaporize everything within 6 miles. Does 4 sound like a lot to you? It shouldn't, because you're about to find out what happens when things go wrong at 30,000 feet with 70,000 pounds of nuclear weapons on board. January 24th, 1961. Seymour Johnson Air Force Base, Goldsboro, North Carolina. It's about noon. The sun is out, but it's cold, mid-30s. A typical winter day in North Carolina. A B-52 Stratofortress sits on the runway, tail number 540490. It's been loaded with fuel, armed with 2 Mark 39 hydrogen bombs, and pre-flighted by the ground crew. Everything checks out. The crew boards, 8 men. The pilot, Major Walter Scott Tulloch. The co-pilot, Captain Richard Rardin. The navigator, Captain Leo Barber. The electronic warfare officer, First Lieutenant Robert Morrison, and 3 other crew members. These aren't rookies. These are experienced Strategic Air Command pilots. They've flown these missions dozens of times. They know the plane, they know the route, they know the stakes. Their mission is simple: take off from Seymour Johnson, fly a patrol route along the East Coast, conduct a mid-air refueling exercise, and return to base. Standard Chrome Dome procedure. They'll be in the air for approximately 24 hours. At 12:40 p.m., the B-52 roars down the runway and lifts off. 170 tons of aircraft, fuel, and nuclear weapons climbing into the sky over North Carolina. Everything is nominal. For the next several hours, the flight proceeds normally. They fly their patrol route. They practice their procedures. They stay in radio contact with command. Just another training mission. Just another day in the Cold War. Around midnight, they rendezvous with a KC-135 Stratotanker for mid-air refueling. This is one of the most dangerous parts of any B-52 mission. The tanker and the bomber have to fly in close formation, often in rough weather, at high altitude, while thousands of pounds of jet fuel are pumped through a hose from one plane to another. It requires absolute precision. The bomber comes up behind the tanker, matches its speed exactly, and extends a refueling boom that connects to the tanker's drogue. If the planes drift too close, they could collide. If they drift too far apart, the boom disconnects and fuel sprays everywhere. It's incredibly difficult and incredibly dangerous. And on this particular night, something goes wrong. The exact cause was never fully determined, but during or shortly after the refueling operation, a leak develops in the B-52's fuel system. It starts small, maybe just a trickle, the kind of thing that might not even register on the instruments at first. But at 30,000 feet, in sub-zero temperatures, with 8 engines burning fuel as fast as it can be pumped through the lines, a small leak can become a big problem very quickly. The crew notices something's wrong when the fuel gauges start dropping faster than they should. They run through their checklists. They check their systems. They try to isolate the leak. But it's getting worse. The leak is growing. Fuel is pouring out of the right wing at an alarming rate. They're losing hundreds, then thousands of pounds of fuel per minute. The plane is becoming unstable. Major Tulloch, the pilot, makes a decision. They need to get back to Seymour Johnson immediately. They're currently over the Atlantic Ocean, east of the coast. He banks the plane west and begins descending toward their home base. But they're not going to make it. The leak has become a torrent. Fuel is hemorrhaging out of the wing. The plane is getting lighter on one side, harder to control. The right wing is losing structural integrity. The aircraft is starting to break apart. At approximately 2:30 a.m., with the plane at around 10,000 feet and descending, the right wing fails. Not fails as in stops working. Fails as in separates from the aircraft. At 200 miles per hour, with 8 men on board and 2 hydrogen bombs in the bomb bay, the B-52 Stratofortress begins to disintegrate in midair. Imagine being on that plane. You're Major Walter Tulloch. You've been flying for over 14 hours. You're exhausted, you're cold, and suddenly your aircraft, this massive machine that you've trusted with your life dozens of times, starts shaking violently. The control stick is fighting you. The plane wants to roll. You're pushing the stick with everything you have, trying to keep the wings level, but it's not responding. You look at your instruments and they're going crazy. Fuel pressure 0, hydraulics failing, altitude dropping. And then you hear it, a sound that no pilot ever wants to hear. Metal tearing. Not groaning, not creaking, tearing. Like someone ripping a tin can in half. The plane lurches. The right wing is gone. You're not flying anymore. You're falling. 170 tons of aircraft, spinning out of control, in the darkness, 30 miles from Goldsboro, North Carolina. You have seconds to make a decision. There's no saving the plane. It's over. The only question is whether you and your crew die in the crash or get out. Bail out, bail out, bail out, Major Tulloch shouts into the intercom. The crew doesn't hesitate. They've trained for this. They know what to do. 5 of the 8 crew members manage to reach their ejection seats or bailout hatches. They pull their handles. Explosive charges fire. Seats rocket out of the disintegrating aircraft. Parachutes deploy. 5 men, floating down through the freezing January night, watching their plane tumble toward the ground below. 3 others aren't so lucky. They either can't reach their seats in time or their ejection systems fail. 3 men die in the crash. 3 men who were just doing their jobs, flying a routine patrol, dead because of a fuel leak. But here's the thing that nobody on that plane was thinking about as they bailed out. Here's the thing that didn't even occur to them until later. The bombs. 2 Mark 39 hydrogen bombs, each weighing 7,600 pounds, each containing a 3.8 megaton thermonuclear warhead, were still in the bomb bay when the plane broke apart. And when the aircraft disintegrated, the bombs were released. They fell. 2 hydrogen bombs falling through the darkness over rural North Carolina. And this is where the story gets absolutely terrifying. Because these bombs weren't just dumb hunks of metal falling to Earth, they were sophisticated weapons systems. And as they fell, they started to do exactly what they were designed to do. They started to arm themselves. You see, the Mark 39 was designed to be dropped from high altitude. When it separates from the aircraft, it goes through an arming sequence. This is intentional. This is by design. The bomb is supposed to arm itself as it falls, so that by the time it reaches its target, it's ready to detonate. Under normal circumstances, a bomber would fly over its target, the bombardier would flip a series of switches in the cockpit to enable the arming sequence, and then the bomb would be released. As it fell, it would go through its arming checklist automatically. Barometric triggers would activate at certain altitudes, timers would count down, electrical circuits would complete, and then, at the programmed altitude, the bomb would detonate. But here's the problem. When the B-52 broke apart over Goldsboro, the bombs weren't released deliberately. They were just torn free. The aircraft was tumbling, breaking into pieces, and the bombs were simply ejected from the bomb bay by the force of the breakup. But the bombs didn't know that. The bombs couldn't tell the difference between a controlled release and a catastrophic accident. All they knew was that they were falling, and their programming said, if you're falling, start arming. So they did. Bomb number 1, the larger of the 2, had a parachute system. This was standard for high-altitude drops. The parachute was designed to slow the bomb's descent, giving it time to complete its arming sequence and allowing the bomber to escape the blast radius. When bomb number 1 separated from the aircraft, the parachute deployed automatically. The bomb began drifting down through the night sky, swinging gently beneath its parachute, descending toward the tobacco fields below. And as it fell, it armed itself. Bomb number 2 didn't have a functioning parachute. Either it didn't deploy, or it was damaged in the breakup. Without a parachute, bomb number 2 went into free fall. It plummeted toward the Earth at terminal velocity, somewhere around 700 miles per hour. 2 different bombs, 2 different trajectories, but both of them were now active nuclear weapons, falling toward the ground, going through their arming sequences. And here's what nobody knew at the time. Here's the classified detail that wouldn't come out for 50 years. 3 of the 4 safety mechanisms on bomb number 1 had already activated. 3 out of 4. The bomb was 1 switch away from detonation. 1 component, 1 trigger, 1 low-voltage arming circuit was all that stood between the United States and a self-inflicted nuclear catastrophe that would have made Hiroshima look like a firecracker. Let me explain exactly how close we came. The Mark 39 hydrogen bomb had 4 primary safety mechanisms, 4 things that had to happen in sequence before the bomb would detonate. These weren't redundant systems, they were sequential. Each one had to activate before the next one could engage. Think of them like a combination lock. You have to get all 4 numbers right in order, or the lock won't open. Here's how they worked. Safety mechanism number 1, the mechanical arming switch. This was a physical device inside the bomb that had to move from safe to armed. Under normal circumstances, this switch would only move when the bomb was released and certain G-forces were detected. The force of being dropped from the aircraft would activate the switch. When bomb number 1 separated from the plane, this switch activated. The tumbling, the violence of the breakup, the sudden acceleration, all of that was enough to trigger the mechanical arming switch. 1 down, 3 to go. Safety mechanism number 2, the electrical arming circuit. Once the mechanical switch was armed, an electrical circuit had to be completed. This required power from the bomb's internal battery and specific signals from the barometric sensors detecting changes in altitude. As bomb number 1 fell through the atmosphere, descending from 10,000 feet toward the ground, the barometric sensors detected the pressure change. The electrical arming circuit activated. 2 down, 2 to go. The timer mechanism. Even with the mechanical and electrical systems armed, the bomb still had a timer that had to count down to 0 before detonation could occur. This timer was designed to give the bomber time to escape the blast radius. Here's the problem. The timer was set when the bomb was loaded, and because this was a training mission, because the crew wasn't planning to actually drop these bombs, the timer was set to a very short interval. Some sources say it was set to just seconds. As bomb number 1 descended under its parachute, the timer counted down, and when it hit 0, the timer mechanism completed its sequence. 3 down, 1 to go. The fourth and final safety mechanism was a low-voltage trigger called the discrete arm switch. This was a separate electrical component that required a specific low-voltage signal to arm the final detonation circuit. Without this signal, even with all the other systems armed, the bomb wouldn't detonate. And this switch, for reasons that nobody has ever fully explained, failed to activate. Maybe it was damaged in the breakup. Maybe it was a manufacturing defect. Maybe it was just dumb luck. But that one switch, that one component, did not complete its circuit. And that's why you're alive to watch this video. If that switch had activated, if that final circuit had closed, bomb number 1 would have detonated at approximately 3:15 a.m. on January 24, 1961, in a field outside Goldsboro, North Carolina. The explosion would have been 3.8 megatons. To put that in perspective, the Hiroshima bomb created a fireball about 1,000 feet in diameter. A 3.8 megaton bomb creates a fireball 2 miles wide. Everything within that 2-mile radius would have been vaporized instantly. Not burned, not destroyed, vaporized. Converted into superheated gas in a fraction of a second. The thermal radiation, the heat wave from the explosion, would have caused third-degree burns on exposed skin up to 8 miles away. That's not 8 miles from the center of the blast, that's 8 miles in every direction, a circle 16 miles wide where everyone outside would have suffered burns severe enough to require immediate hospitalization. The shock wave would have leveled every building, every house, every structure within 6 miles. We're not talking about broken windows, we're talking about total destruction. Reinforced concrete buildings reduced to rubble, wooden houses turned into splinters. Goldsboro would have ceased to exist. Population, 17,000? Gone. The nearby city of Fayetteville, home to Fort Bragg, one of the largest military bases in the world. Massive casualties. Raleigh, the state capital, 60 miles away. Extensive damage. Durham, Wilson, Kinston, Rocky Mount, all would have been hit. And then there's the fallout. A ground burst, which this would have been, kicks up millions of tons of dirt and debris into the mushroom cloud. That material becomes radioactive. It rises into the atmosphere, and then it falls back down, carried by the wind. In January 1961, the prevailing winds over North Carolina were blowing northeast. Computer simulations done years later showed that the fallout plume from a 3.8 megaton ground burst at Goldsboro would have extended from eastern North Carolina, across Virginia, Maryland, Delaware, and into Pennsylvania and New York. We're talking about radioactive contamination of Washington, D.C., Baltimore, Philadelphia, possibly even New York City. Tens of millions of people exposed to lethal doses of radiation. Hundreds of thousands of deaths in the immediate aftermath. millions more from long-term radiation exposure. The economic impact would have been incalculable, the political implications unthinkable. America, the leader of the free world, the nation that was supposed to protect its citizens from nuclear war, would have accidentally nuked its own East Coast. One switch, one component, one piece of circuitry that happened to fail at exactly the right moment. That's what saved us. And bomb number 2? The one that didn't have a parachute? The one that slammed into the ground at 700 miles per hour? That one didn't detonate either. Not because its safety systems worked, but because it hit so hard, so fast, that it buried itself deep in the muddy soil before its arming sequence could complete. The impact created a crater, a big one, and the bomb, all 7,600 pounds of it, punched through the soft earth and disappeared underground. And here's the crazy part. It's still there. I'm not kidding. Bomb number 2 is still buried in a field outside Goldsboro, North Carolina. Right now, as you're watching this video. Let me tell you what happened next. By sunrise on January 24th, word had reached Strategic Air Command headquarters that a B-52 had gone down. The initial reports were confused. There were survivors, but there were also casualties. The plane had broken apart. And most importantly, the nuclear weapons were unaccounted for. Within hours, recovery teams were on site. This wasn't just a crash investigation. This was a nuclear emergency. 2 hydrogen bombs, each capable of destroying a city, were somewhere in the fields and swamps outside Goldsboro. Bomb number 1 was easy to find. Its parachute had gotten tangled in a tree, and the bomb was hanging there, suspended 15 feet off the ground, clearly visible. The recovery team approached it carefully, very carefully. Because here's the thing, they didn't know if it was armed. They didn't know if it was stable. They didn't know if moving it might trigger the detonation sequence. For all they knew, they were looking at a live nuclear weapon that could go off at any moment. Lieutenant Jack Revell was the bomb disposal expert in charge of the recovery. Years later, in an interview, he described what it was like to approach that bomb. He said that when he first saw it, hanging there in the tree, he felt his blood run cold, because he could see that the arming panel was showing green. Green meant armed. Green meant that the weapon had gone through its sequence and was ready to detonate. He climbed up to the bomb, carefully, and examined the arming mechanisms, and that's when he discovered the truth. 3 out of 4 safeties had activated. The bomb was one switch away from detonation. Revell later said, and this is a direct quote, "How close was it to exploding? My opinion is damn close. You might now have a very large Bay of North Carolina if that thing had gone off." Think about that. A Bay of North Carolina. He's talking about a crater so large it would have flooded with water from the Atlantic Ocean and created a new geographical feature, a permanent scar on the map of the United States. The team carefully disarmed bomb number 1, detached it from the tree, and transported it to a secure facility. Crisis averted. But bomb number 2 was a different story. The second bomb had hit the ground so hard that it created a crater 50 feet deep. The impact had been tremendous. 7,600 pounds traveling at 700 miles per hour, hitting soft, waterlogged soil. The bomb had punched through the earth like a bullet through tissue paper, and then it had kept going, down through the soil, through the clay, through the groundwater, until it finally came to rest somewhere deep underground. The recovery team brought in heavy equipment, cranes, excavators, drilling rigs. They dug and dug and dug. They went down 50 feet, 75 feet, 100 feet. They found pieces of the bomb, the tail section, parts of the casing, fragments of the arming mechanisms. But they never found the core. They never found the uranium. They never found the secondary stage, the fusion component that would have created the megaton-scale explosion. It was just gone, buried too deep to recover. Somewhere under a field in North Carolina, there is a thermonuclear weapon core. Still there, still radioactive, and it's going to stay radioactive for a very, very long time. Uranium-235, the primary fissile material in the bomb, has a half-life of 700 million years. That means in 700 million years, half of it will have decayed. In another 700 million years, half of what's left will decay. It's going to be radioactive essentially forever by human timescales. So what did the government do? They kept digging for a while, but eventually they gave up. The bomb was too deep. The risk of trying to excavate it was too high. So they made a decision. They bought the land. The federal government purchased the property, declared it off limits, and sealed it. To this day, if you go to that site, there's nothing there. Just a field. No marker, no monument, no sign that says, "Warning, hydrogen bomb buried here." Just a field where nothing is allowed to be built and nobody is allowed to dig. And what did the government tell the public? Nothing. For decades, the official story was that there had been a minor accident. A B-52 had crashed, there were casualties, but the nuclear weapons had been recovered safely and there was never any danger to the public. That was a lie. It wasn't until 1986, 25 years after the accident, that journalist Joel Dobson uncovered the truth and published the first detailed account of what really happened. And even then, the government denied it. They said Dobson's reporting was exaggerated. They said the bombs were never armed. They said there was never any real danger. It wasn't until 2013, 52 years after the accident, that the government finally admitted the truth. A Freedom of Information Act request forced the declassification of documents from the Department of Defense that confirmed everything. The bombs were armed. 3 out of 4 safeties had failed. America came within one switch of a nuclear catastrophe. Why did they hide it? Why did they lie for 50 years? Because admitting the truth would have been catastrophic. It would have shattered public confidence in the military. It would have raised questions about nuclear safety that the government didn't want to answer. It would have forced a reckoning with the fact that our own weapons were just as dangerous to us as Soviet weapons. So, they buried it, literally and figuratively. But here's the thing that should really terrify you. Goldsboro wasn't unique. It wasn't even the worst accident. It was just one of many times that America almost destroyed itself with its own nuclear weapons. And most of those stories are still classified. Let me tell you about some of the ones we know about. Tybee Island, Georgia, February 5, 1958. A B-47 bomber is on a training mission off the coast of Georgia when it collides mid-air with an F-86 fighter jet. The B-47 is carrying a Mark 15 hydrogen bomb, 7,600 pounds, 1.7 megatons. The collision damages the bomber. The pilot realizes he can't land with the bomb on board. It's too heavy, the plane is too damaged, and there's a risk it could detonate on impact. So he does what he's been trained to do in an emergency. He jettisons the bomb. He drops a hydrogen bomb into the Atlantic Ocean, just off the coast of Tybee Island, near Savannah, Georgia. The military immediately begins search and recovery operations. They bring in divers, sonar equipment, everything they have. They search for weeks. They never find it. To this day, there is a hydrogen bomb sitting on the bottom of the Atlantic Ocean, somewhere off the coast of Georgia. The military claims it's not armed. They say there's no danger. They say the bomb is in a safe condition and the radioactive material is contained. But here's the thing. They don't actually know because they never found it. For all we know, that bomb is corroding. The casing is degrading. The plutonium is leaking into the ocean. Or maybe it's fine. Maybe it'll sit there for 1,000,000 years, buried in sand, perfectly safe. But we don't know. And we'll never know, because we can't find it. There is a hydrogen bomb off the coast of Georgia, and we have no idea where it is. Damascus, Arkansas, September 18th, 1980. This one is almost darkly comedic if it weren't so terrifying. The United States had a network of Titan II intercontinental ballistic missiles. These were massive rockets stored in underground silos, each one topped with a 9-megaton thermonuclear warhead. 9 megatons, more than twice the size of the Goldsboro bombs. These missiles were kept on high alert, ready to launch at a moment's notice. There were crews working on them constantly, performing maintenance, running checks, keeping them operational. On September 18th, 2 Air Force technicians were performing routine maintenance on a Titan II missile in its silo near Damascus, Arkansas. One of them was at the top of the missile, about 70 feet above the silo floor, working on a pressure valve. He needed to remove a socket from a wrench. He dropped it. A socket wrench, about 8 inches long, probably weighed less than 2 pounds. It fell 70 feet, bounced off a platform, and punctured the missile's fuel tank. Now, Titan II missiles used a fuel called Aerozine 50. It's hypergolic, which means it ignites spontaneously when it comes in contact with the oxidizer. And it's incredibly toxic. Exposure to the fumes can kill you in seconds. When the socket punctured the tank, fuel started leaking. Not a lot at first, just a trickle. But the pressure inside the tank was enormous, and the trickle quickly became a stream. The crew evacuated the silo immediately. They called in emergency response teams. They tried to vent the fumes, to stabilize the pressure, to stop the leak, but nothing worked. For 9 hours, fuel poured into the silo. The fumes built up, the pressure increased. Everyone knew what was going to happen, they just didn't know when. At 3 a.m., the missile exploded. Not a nuclear explosion, the warhead didn't detonate, but the fuel and oxidizer mixed and ignited, creating a massive conventional explosion. The blast blew the 740-ton silo door, a massive steel and concrete cap, into the air like a frisbee. It landed 100 yards away. The explosion threw the warhead, all 9 megatons of it, out of the silo and into a ditch. 1 person was killed, 21 were injured. And the 9-megaton nuclear warhead, it just lay there, in a ditch. In Arkansas. The official report stated that the warhead was in safe condition and there was never any danger of a nuclear detonation. But think about what happened. A massive explosion, enough force to throw a 740-ton steel door 100 yards, and somehow, miraculously, the warhead didn't detonate. Do you believe that was by design? Or do you think maybe we just got lucky? A dropped wrench. That's all it took. A dropped wrench nearly caused a 9-megaton nuclear explosion in Arkansas. Palomares, Spain. January 17, 1966. A B-52 bomber is flying a Chrome Dome mission over the Mediterranean Sea. It's carrying 4 hydrogen bombs, 4 B-28 thermonuclear weapons, each with a yield of 1.1 megatons. The bomber is scheduled for mid-air refueling. It approaches the KC-135 tanker, begins the refueling process, and then something goes wrong. The 2 planes collide. The explosion is catastrophic. Both aircraft are destroyed instantly. 7 of the 11 crew members die, and the 4 nuclear bombs fall. 2 of them land in the Mediterranean Sea and sink. The Navy eventually recovers them after an extensive search operation that takes months. But the other 2 land on Spanish soil in the village of Palomares, And when they hit the ground, their conventional explosives detonate. Now, to be clear, the nuclear warheads did not detonate, but the bombs used conventional explosives as part of their triggering mechanism. When you set off a nuke, you first use conventional explosives to compress the plutonium core. That compression creates the critical mass needed for a nuclear chain reaction. When these two bombs hit the ground, the conventional explosives went off. They didn't compress the plutonium enough to start a nuclear reaction, but they did scatter it. They essentially turned two hydrogen bombs into dirty bombs. Plutonium sprayed across the Spanish countryside. Fields, farms, homes, all contaminated with one of the most toxic substances known to science. The U.S. military's response was massive. They brought in cleanup crews, heavy equipment, scientists, engineers. They removed 1,400 tons of contaminated soil and vegetation. They scrubbed buildings, they tested the ground, the water, the crops. And then they shipped all that contaminated material back to the United States and buried it in South Carolina. The Spanish government was, understandably, not happy. This was an American accident on Spanish soil. American bombs had contaminated a Spanish village. The political fallout was almost as bad as the radioactive fallout. To this day, parts of Palomares are still contaminated. There are areas where the plutonium concentration is above safe levels. The Spanish government still monitors the site, still tests the soil, still warns people not to dig. All because a B-52 collided with a tanker during a routine refueling. Thule Air Base, Greenland, January 21st, 1968. Another B-52, another Chrome Dome mission, this time flying over Greenland, one of the most remote places on Earth. The bomber is carrying 4 hydrogen bombs. It's 7 hours into its mission when a cabin heater malfunctions and starts a fire. The crew tries to fight the fire, but it's spreading too fast. The smoke is overwhelming. They can't see, they can't breathe. The pilot makes an emergency descent, trying to reach Thule Air Base before the plane becomes uncontrollable. They almost make it. They're just 7 miles from the runway when the fire burns through critical control cables. The plane becomes unflyable. The pilot gives the order to bail out. 6 crew members eject, 1 dies. The B-52, now pilotless, crashes into the ice near Thule. The impact and subsequent fire caused the conventional explosives in all 4 bombs to detonate. Plutonium scatters across the ice. The intense heat melts the ice, and radioactive material sinks into the ocean. The cleanup operation is a nightmare. Greenland in January, sub-zero temperatures, constant darkness, ice everywhere, and somewhere in this frozen hell, there is plutonium. The military brings in hundreds of personnel. They work in brutal conditions, collecting contaminated ice and snow, trying to recover as much of the radioactive material as possible. The operation lasts months. They recover 3 of the 4 bombs. Mostly, they find pieces of the weapons, fragments of the plutonium cores, bits of the arming mechanisms. But the 4th bomb? Never fully accounted for. Some of it was recovered, but some of it is still out there, somewhere under the ice or at the bottom of the ocean near Thule. The Danish government, which controlled Greenland at the time, was furious. They hadn't been told that American bombers were flying nuclear weapons over their territory. The accident forced the U.S. to admit that it had been conducting these flights for years without informing the Danes. The political consequences were severe. Denmark demanded an end to the flights. The U.S. eventually agreed to suspend Chrome Dome operations. But by then, the damage was done. 4 nuclear accidents, bombs lost in the ocean off Tybee Island, an explosion in Arkansas, plutonium contamination in Spain, radioactive material in Greenland. And these are just the ones we know about. These are the incidents that were eventually declassified, that were investigated, that made it into the public record. How many more were there? How many accidents were covered up? How many near misses were classified and have stayed classified? We don't know, and we may never know. So why did all this happen? Why did America repeatedly almost nuke itself? The answer is complicated, but it comes down to a few key factors. First, the Cold War created an environment of constant,
high-stakes pressure. The threat of Soviet nuclear attack was considered so serious that we were willing to take enormous risks to maintain our readiness. We kept bombers in the air 24/7 loaded with nuclear weapons because we believed that was the only way to ensure we could retaliate if the Soviets struck first. But that strategy came with costs. Planes in the air constantly mean more opportunities for accidents, mechanical failures, human error, bad weather, mid-air collisions. All of these become much more likely when you're flying thousands of missions a year. Second, the technology was pushed too far too fast. The B-52 was designed in the early 50s. The hydrogen bombs were developed in the early 50s. We went from the first atomic bomb in 1945 to thermonuclear weapons on long-range bombers in less than a decade. The systems were complex, the weapons were new, the procedures were still being developed. We were figuring it out as we went along, and we were making mistakes. And third, safety was secondary. I know that sounds harsh, but it's true. The primary design goal for Cold War nuclear weapons was reliability. The military wanted bombs that would work when needed. Safety mechanisms were added, sure, but they were not the top priority. The Mark 39 bomb that almost detonated over Goldsboro had 4 safety mechanisms. That sounds like a lot until you realize that 3 of them failed. 3 out of 4. What kind of safety system has a 75% failure rate? A system that wasn't really designed for safety. It was designed for function. And fourth, there was a culture of secrecy. When accidents happened, the immediate response was to classify everything, lock it down, and tell the public as little as possible. This meant that lessons weren't learned, mistakes were repeated, problems weren't fixed because nobody outside a small group of military officials even knew there were problems. Goldsboro should have been a wake-up call. It should have forced a complete redesign of nuclear safety protocols. But because it was classified, because the public never knew how close we came, nothing changed. The flights continued, the weapons stayed the same, and more accidents happened. It wasn't until the Palomares of Thule incidents, which were impossible to hide because they happened on foreign soil, that the US finally started making changes. Chrome Dome was suspended, new safety features were added to weapons, procedures were updated.
But by then, we'd already lost bombs in the ocean, scattered plutonium across 2 continents, and come within 1 switch of vaporizing the East Coast. All to deter an enemy that, as far as we know, never seriously considered launching a first strike. So what about today? Could this happen now? The good news is that nuclear safety has improved dramatically since the 1960s. Modern nuclear weapons have far more sophisticated safety features. They use things like permissive action links that require multiple codes to be entered before the weapon can be armed. They have environmental sensors that can detect if the weapon is being handled improperly. They have encrypted communication systems that prevent unauthorized arming. And we're not flying Chrome Dome missions anymore. There are no B-52s loaded with hydrogen bombs circling overhead right now. The United States switched to a different deterrence strategy, relying more on submarine-launched ballistic missiles and land-based ICBMs rather than airborne bombers. But here's the uncomfortable truth. We still have nuclear weapons, thousands of them, and they're still managed by humans, and humans make mistakes. In 1995, Russian radar systems detected what appeared to be an incoming submarine-launched ballistic missile heading toward Moscow. The Russian military went on high alert. They activated their nuclear briefcase. They prepared to launch a retaliatory strike. For several minutes, the fate of the world hung in the balance. Russian President Boris Yeltsin had to decide whether to launch Russia's nuclear arsenal based on what his radar was telling him. It turned out to be a Norwegian scientific rocket studying the aurora borealis, a weather rocket, not a missile. But the Russian systems couldn't tell the difference. Yeltsin chose not to launch, but he came very close. Some reports suggest he actually opened the nuclear briefcase and was moments away from giving the order. That was 1995, after the Cold War ended, after we supposedly learned our lessons.
In 2007, a B-52 at Minot Air Force Base in North Dakota was being loaded with cruise missiles for a flight to Barksdale Air Force Base in Louisiana. The crew mistakenly loaded 6 missiles armed with nuclear warheads instead of dummy warheads. The plane flew from North Dakota to Louisiana with 6 nuclear weapons on board. Nobody noticed. Not the loading crew, not the pilots, not the ground crew at Barksdale. It wasn't until 36 hours later, when someone was doing an inventory check, that anyone realized nuclear weapons had been lost track of. 6 nuclear weapons. Lost. For 36 hours. The incident led to multiple investigations, the resignation of senior Air Force officials, and major changes to nuclear handling procedures. But it also revealed something disturbing. Even with all our modern safety systems, even with all our training and protocols, we can still lose track of nuclear weapons. And then there are the cybersecurity concerns. Modern nuclear weapon systems are computerized, they're networked, and that means they're potentially vulnerable to hacking. In 2010, the Stuxnet virus successfully infiltrated and sabotaged Iran's nuclear program. It was a sophisticated cyber weapon, probably created by the United States and Israel, that physically destroyed centrifuges by causing them to spin out of control while reporting normal operation to the monitoring systems. If we can do that to Iran, what could Russia or China do to us? What could a sophisticated hacker do if they gained access to nuclear command and control systems? The military says these systems are air-gapped, not connected to the internet, impossible to hack remotely. But we said the Iranian systems were secure too, and Stuxnet still got in. I'm not trying to be alarmist. I'm not saying a nuclear accident is imminent or inevitable. What I am saying is that the risk hasn't gone away. It's changed form, but it hasn't disappeared. We still have thousands of nuclear weapons. They're still on high alert. They're still managed by complex systems that can fail. And they're still controlled by humans who can make mistakes. The Bulletin of the Atomic Scientist maintains something called the Doomsday Clock. It's a symbolic representation of how close humanity is to catastrophic destruction. Midnight represents the end of the world. In 1991, after the Cold War ended, the clock was set to 17 minutes to midnight, the furthest from midnight it had been in decades. Today, as I'm recording this, the clock is set to 90 seconds to midnight, the closest it has ever been. Not because of accidents, because of tensions between nuclear powers, because of the war in Ukraine, because of deteriorating arms control agreements, because of new weapons technologies. We like to think we're past the Cold War. We like to think nuclear weapons are a problem we solved. But the truth is, we're living in a world with more nuclear powers than ever before. The United States, Russia, China, France, the United Kingdom, India, Pakistan, Israel, and North Korea all have nuclear weapons. And many of these countries don't like each other. India and Pakistan have fought multiple wars. They both have nukes now. North Korea threatens South Korea and Japan regularly. It has nukes now. Russia and NATO are in a proxy war in Ukraine. Both sides have thousands of nukes. The infrastructure is aging. The treaties are expiring. The geopolitics are getting more complicated. And we're supposed to believe that no one will ever make a mistake? That no system will ever fail? That no accident will ever happen? Goldsboro taught us something important. It taught us that the most dangerous thing about nuclear weapons isn't the enemy using them against us. It's us using them against ourselves. One switch. That's all that saved us. One piece of circuitry that happened to fail at exactly the right moment. How many more times can we get that lucky? Let me bring this full circle. Let's go back to Goldsboro, North Carolina. If you drive through Goldsboro today, you'd never know what happened there. It's still a small town. Population's actually smaller now than it was in 1961, down to about 15,000. It's quiet, rural, unassuming. There's no monument to what almost happened. No memorial, no plaque. Nothing to mark the spot where America came within one switch of annihilating itself. The field where bomb number 2 is buried looks like any other field. There's no fence, no warning signs, just farmland. If you didn't know the history, you'd drive right past it and never give it a second thought. But if you did know the history, if you understood what's under that ground, you'd probably find it hard to look away. Because buried in that field, under 30 or 40 feet of North Carolina soil, is a piece of history that we tried to forget. A reminder of how close we came. A testament to our hubris and our luck in equal measure. The uranium core is still there, still radioactive. It'll be radioactive for hundreds of millions of years. Long after America is gone, long after human civilization is gone, that uranium will still be there, slowly decaying, releasing radiation into the surrounding soil. In a way, it's a perfect metaphor for the nuclear age. We built these weapons thinking we could control them, thinking we could manage the risk, thinking we were smart enough, careful enough, disciplined enough to handle the most destructive force humans have ever created. And then we dropped one, by accident, and it almost went off, and we lost another one and couldn't get it back. We scattered plutonium across Spain. We dropped a bomb in the ocean off Georgia and never found it. We had an explosion in Arkansas that threw a 9-megaton warhead into a ditch. We contaminated the ice in Greenland. And these are just the accidents we know about. The Goldsboro incident was declassified in 2013, 52 years after it happened. More than half a century of lying to the public about how close we came. What else are they not telling us? What other near misses are still classified? How many other times did we come within one switch, one decision, one stroke of luck, of a catastrophe? We may never know. Some of these incidents are probably still classified. Some of the documents have probably been destroyed. Some of the people who were there have died without ever being allowed to tell their stories. But what we do know is enough. What we do know should terrify us. Because the lesson of Goldsboro isn't just that accidents happen, it's that accidents with nuclear weapons are catastrophic. There's no margin for error. There's no minor nuclear accident. Either the bomb goes off or it doesn't. Either you vaporize a city or you don't. And we've been relying on luck. For 70 years, we've been relying on luck. That last safety switch on the Goldsboro bomb? Luck. The fact that the Damascus warhead didn't detonate when the missile exploded? Luck. The fact that the Palomares bombs didn't achieve critical mass when their conventional explosives went off? Luck. How long can that continue? How many more accidents can we survive? How many more times can we roll the dice and come up safe? I don't have an answer to that. Nobody does. But I think it's worth asking the question. There's a concept in nuclear strategy called nuclear deterrence. The idea is that as long as everyone has nuclear weapons, no one will use them, because using them would guarantee your own destruction. Mutually assured destruction. MAD. And for the most part, it's worked. We haven't had a nuclear war. No nuclear weapon has been used in combat since Nagasaki in 1945. That's 80 years of nuclear peace, if you can call it that. But nuclear deterrence only accounts for intentional use. It only works if everyone is acting rationally, if everyone understands the consequences, if everyone follows the rules. It doesn't account for accidents. It doesn't account for mechanical failures, human error, dropped wrenches, fuel leaks, mid-air collisions, cabin fires. And that's the real danger. Not that someone will deliberately start a nuclear war, but that someone will accidentally start one. Imagine if the Goldsboro bomb had detonated. 3.8 megatons, ground burst in the middle of North Carolina. Tens of thousands dead instantly. Hundreds of thousands more from radiation. What would the Soviet Union have thought? Would they have believed it was an accident? Or would they have assumed it was an American first streak, a decapitation attempt that had gone wrong? Would they have launched their weapons in response? Would we have assumed their response was an unprovoked attack? Would we have launched ours? One accident, one mechanical failure, one fuel leak, and the whole house of cards comes tumbling down. That's what keeps defense analysts up at night. Not intentional nuclear war, accidental nuclear war. And the Goldsboro incident proves that it's possible. It proves that we can come within one switch of catastrophe. It proves that our safety systems can fail. It proves that luck is sometimes the only thing standing between us and annihilation. So what do we do about it? I wish I had a simple answer. I wish I could tell you that there's an easy solution, a policy change, or a technology upgrade that would eliminate the risk. But the truth is, as long as nuclear weapons exist, the risk exists. You can improve safety systems, you can reduce the number of weapons, you can implement better procedures and training, but you can't eliminate the possibility of an accident. Some people argue for complete nuclear disarmament. Get rid of all the weapons, eliminate the risk entirely. It's a nice idea, but it's probably not realistic. You can't uninvent nuclear weapons. The knowledge exists, and as long as it exists, there's the possibility that someone, somewhere, will build more. Others argue for minimum deterrence. Keep just enough weapons to ensure that any attack would be met with devastating retaliation, but not so many that an accident would be catastrophic. Reduce the numbers, reduce the risk. That's probably the most realistic approach, but it requires international cooperation, arms control agreements, verification systems. And right now, we're moving in the opposite direction. Treaties are expiring, arms control is breaking down, countries are modernizing their arsenals. The truth is, we're probably stuck with nuclear weapons for the foreseeable future, which means we're stuck with the risk of accidents. All we can do is try to minimize that risk, try to learn from past mistakes, try to build better safety systems, try to be more careful, more vigilant, more aware of how close we've come and how close we could come again. And maybe, just maybe, talk about it. Shine a light on these incidents. Make sure people know what happened at Goldsboro, at Palomares, at Thule, at Damascus, at Tybee Island. Because secrecy doesn't make us safer. Hiding accidents doesn't prevent future accidents. Lying to the public doesn't build confidence in our nuclear program. Transparency does. Accountability does. Learning from mistakes does. The Goldsboro incident was classified for 50 years because the government was afraid of what would happen if people knew the truth. They were afraid of public panic, of loss of confidence, of political consequences. But you know what's scarier than people knowing we almost nuked ourselves? People not knowing. People thinking nuclear weapons are perfectly safe. People believing that accidents can't happen. Because if we don't know how close we've come, we won't know how careful we need to be. So here we are, almost 64 years after a hydrogen bomb fell from the sky over North Carolina and came within one switch of detonating. The crew members who survived that crash are mostly gone now. The pilots, the engineers, the recovery teams. They've passed away or they're in their 80s and 90s. The B-52 that broke apart that night was scrapped decades ago. The bombs were dismantled. The evidence was classified. But the uranium core is still there, buried in a field outside Goldsboro, slowly decaying, releasing radiation, a silent and visible reminder of what almost happened. And there's a hydrogen bomb at the bottom of the Atlantic Ocean off Tybee Island, still there, still lost. And there's plutonium in the soil in Palomares, still there, still radioactive. And there's contamination in Greenland, still there, still monitored. These aren't ancient history. These aren't distant Cold War relics. These are ongoing situations, active contamination sites, lost weapons that were never recovered. This is the legacy of the nuclear age. Not just the weapons themselves, but the accidents, the near misses, the mistakes, the luck. We built weapons powerful enough to end civilization. And then we almost use them on ourselves multiple times. That should scare you. It should make you uncomfortable. It should make you question our relationship with these weapons. Because the next time, we might not get lucky. The next time, that fourth safety switch might not fail. The next time, the conventional explosives might compress the plutonium just enough. The next time, the bomb might not bury itself too deep to detonate. The next time, we might not be able to make a video about how close we came. Because there might not be anyone left to make it. That's the truth that was hidden for 50 years. That's the truth the government didn't want you to know. We built weapons that could destroy us, and then we almost destroyed ourselves with them. And we keep building more. One switch. That's all that saved us. How many more times can we get that lucky? If you've made it this far, thank you for watching. I know this was long. I know it was heavy. But I think this story needs to be told. Not to scare people, but to inform them. To make sure we remember what happened and what almost happened. The Goldsboro incident isn't just a historical curiosity, it's a warning. A reminder that the greatest threat we face might not be our enemies. It might be our own weapons. We like to think we're in control. We like to think we've mastered the atom, that we've tamed the power of the sun, that we can safely manage these weapons of unimaginable destruction. But a fuel leak and a broken wing taught us otherwise. A dropped wrench in Arkansas taught us otherwise. A cabin fire over Greenland taught us otherwise. We're not in control. We're just lucky. And luck runs out. I hope that the next time someone talks about nuclear weapons, about deterrence, about the balance of power, they remember Goldsboro. They remember that one switch. They remember how close we came. Because if we forget, we're doomed to repeat it. And next time, we might not be so lucky. There's still a hydrogen bomb buried in a field in North Carolina. Right now, as you're listening to this. It's been there for 64 years. It'll be there for millions more. A monument to our hubris, a testament to our luck, and a warning about what could happen if that luck runs out. Remember Goldsboro. Remember that one switch. And remember how close we came to the day America nuked itself.